The universe is a tremendous structure comprised of an infinite multitude of all sorts of diverse objects. They lie so far apart in endless expanses of space that even light gets lost in their depths. It takes a photon traveling from the Sun over 4 years to reach our nearest star. As for covering intergalactic distances, it takes millions of years. When you realize that all this enormous distance is just a tiny molecule on the scale of the macrocosmos, it can't but amaze. So what is the real size of the universe? The solar system is just one of the countless multitude of planetary systems scattered across our galaxy. As we know, it consists of a single star in its main sequence stage and 8 planets with their satellites. In addition, our system contains over 1 million small celestial bodies like asteroids, comets and meteoroids. The planet in the solar system lying furthest, at least that we know of, is Neptune. Its orbit's radius measures around 30 astronomical units, which is equivalent to approximately 4 light-hours. Amazingly, only a tiny portion of the solar system is encompassed by Neptune's orbit. The remotest object in the system discovered to date is the so-called Far Far Out, lying 132 astronomical units, or 18 light-hours away from the Sun. Still, even this object, barely visible against a dark background of unfathomable space, is not at all close to the hypothetical Oort cloud, whose inner boundaries lie approximately 2,000 astronomical units away from the center of our system. According to some estimates, its outer boundaries stretch for up to 60,000 astronomical units at the very least, which is around 1 light-year. These limits are predefined by the Sun's gravitational influence, and what lies beyond is interstellar space. Moving further away, we will notice over 50 of all kinds of stars within 20 light-years from the Sun. These stars are really diverse, from dim and cold brown dwarfs to bright and widely known objects like Sirius, Procyon and Altair. Some of them have their own planetary systems, with objects potentially capable of nursing and sustaining life. For example, the object known as Gliese 832c, which is 16.1 light-years away from the Sun, is similar to our Earth more than any other planet within the solar system that we know of. The average temperature on the exoplanet's surface reaches to 153 Kelvin, or 20 degrees Celsius below zero, and it takes the astronomical body just 36 Earth days to complete a full orbit around its parent star. In astronomical standards, the distance between us and Gliese 832c is relatively small. However, a space probe setting out from our system at a speed of roughly 17 km per second would take as much as 300,000 years to reach the exoplanet's environs. At our current level of technological advancement, it is impossible to design an interstellar spaceship capable of completing as long a journey as that. The solar system, together with its neighbor stars, is part of the Orion Arm. The latter, in its turn, is part of the Milky Way. It contains around 400 billion stars, and potentially over 1 trillion exoplanets of all sorts can be discovered there, according to estimates today. The main diameter of the Milky Way measures around 100,000 light-years, and the stellar halo may be twice as large. Even though the thickness of the main disk measures about 1,000 light-years, there is a clearly defined bulge in the galaxy's center. This bulge is roughly 3,000 light-years thick. The Milky Way is part of the so-called local group. This is a vast structure comprising over 50 galaxies concentrated within an area of space measuring around 10 million light-years in diameter. The Andromeda Galaxy, the Triangulum Galaxy and the Milky Way are the largest of the lot. Some estimates show that the mass total of the cluster may reach as much as 3 trillion solar masses, with our galaxy and Andromeda accounting for the major part. With the distance from the Earth to Andromeda around 2.5 million light-years, it is considered to be our closest galaxy, not counting smaller or dwarf ones. Moving on to the next order, The local group forms part of the giant Virgo supercluster made up of over 30,000 galaxies. The supercluster is located within an area of space with a diameter of around 150 million light-years. Its mass total is as much as a quadrillion solar masses, or in other words, around 1,000 galaxies like the Milky Way. The supercluster is quite flattened, and around 60% of all the objects it is made up of appear like a flat sheet around 10 million light-years thick. Staggering though it may appear on the face of it, this value is actually small in terms of the large-scale structure of the universe. As we zoom out still more, we have a chance of seeing a giant supercluster of galaxies approximately 520 million light-years in size. Called Laniakea, it includes several galaxy superclusters, among others the Virgo supercluster and the Great Attractor. The overall mass of this formation measures approximately as much as 100 quadrillion solar masses. The Great Attractor lies roughly 250 million light-years away from our planet and is the gravitational center for all objects lying close by astronomical standards. It cannot be observed from the Earth directly, as the Milky Way's plane thwarts it. That is why the nature of the Great Attractor still remains an unsolved mystery today. Laniakea is part of the large-scale structure of the universe, an elaborate system of galactic filaments, walls and voids, gargantuan areas of emptiness in space. Some of these objects are really incredibly enormous. For example, the Hercules Corona Borealis Great Wall stretches for around a staggering 10 billion light-years. Ever since its discovery in 2013, this superstructure has been considered the most gigantic component of the large-scale structure of the universe. To all appearances, it must be home to millions of galaxies, and the number of stars it contains will probably always defy calculation. The mere existence of a structure like that is a mystery to science, as according to today's accepted theory of universe's evolution, gargantuan clusters like that are simply not supposed to form. But incidentally, this wall, so enormous that the human brain cannot fully appreciate its dimensions, is still just a tiny portion of the observable universe. According to today's cosmological notions, space in the universe is continually expanding, with the speed of expansion depending on the distance between objects. The further an observed object lies away from the observer, the faster the distance between the two increases. The rate at which the two mutually recede is not limited by the speed of light, because it's actually space matter that is expanding, which means that at a certain point the two objects will be mutually unobservable. Relic radiation observation shows that the area of the observable universe is a sphere, with a diameter roughly 93 billion light-years. According to the theory of relativity, we can see and interact with only those objects that are within this sphere. This conventional spherical area in space is called the meta-galaxy, and it may be either all of the universe, or again its tiny portion. For all we know, hypothetically, there may well lie some unknown structures beyond the visible boundaries of space. Such entities are referred to as extra-metagalactic objects, and unfortunately it is impossible to study them today with scientific methods. Still, some astronomical bodies on the edge of the visible universe appear to be moving in ways different from what we would naturally expect, judging by the data we have. Instances of anomalous movements like those may be evidence of the presence of some massive structures beyond the metagalaxy boundaries. Their attraction pervades the space around and influences objects around too. There is a whole plethora of hypotheses as to the structure of the universe beyond the metagalaxy, but most of them are rather of metaphysical nature. For example, some people believe that time and space as we more or less know them are non-existent beyond the boundaries of the universe. The physical laws we're used to do not apply there either, and notions of matter, material or energy are virtually senseless. This hypothesis is further elaborated on by the following idea. The metagalaxy accounts for just a part of a yet more complex and larger-scale superstructure in space whose makeup and dimensions are too incredible for us to imagine. It is quite possible that this structure could be in a multidimensional space, or else be based on physical principles we have no idea of. This makes the meta-galaxy just an insignificant addition to, or a partial reflection of, this mind-boggling superstructure. According to some interpretations of the anthropic principle, there are other worlds out there beyond the boundaries of the observable universe. In those worlds, the values of the fundamental constants like the speed of light or the electron charge are completely different. This hypothesis is in many ways supported by the idea of a multiverse, which schematically appears as foam with lots of bubbles separated from each other by thin walls, but these walls are impenetrable. This makes every universe a separate space, with its own physical laws, and for all we know, these laws may be totally different from the ones we're used to. The most radical hypotheses go as far as to deny our world any objective reality whatsoever. According to these, the universe is just a simulation like virtual reality in computers, but on an incredibly advanced level. As a rule, ideas like that imply that there are some super beings or super civilizations out there beyond the reality we're used to, whose level of advancement is infinitely higher than ours and whose goals and capabilities are arcane and incomprehensible. However, it goes without saying that it is hardly possible to either confirm or repudiate these hypotheses. Of course, distances in space defy our imagination and are even frightening. They appear infinite from the point of view of any person today. What we do know is that the universe is expanding, and provided this process continues, there will come a point when space objects will disappear one after another beyond the event horizon. First galaxies, then stars, and the world will immerse in eternal darkness. But by then, there will be no one around to witness that.